So for all the people present here, thank you for coming. So I would like to present you Professor Heiko Hecht. So at the moment, correct me if I'm wrong, you are field head of the Department of General Experimental Psychology in the Johannes Gutenberg University in Mainz, correctly? Yeah.
Yeah, so, almost. Johannes Gutenberg, yeah. Mm-hmm.
Yeah. So Professor Hecht did his PhD in the University of Virginia, and then several positions of postdoctoral research, including the Ludwig Maximilian University in München, the NASA Ames Research Center, the MIT Man Vehicle Laboratory, among others. So you have been doing some research in artificial gravity, intuitive physics, picture perception, motion sickness, perception and action in extreme environments, virtual reality, also some things on representational momentum, if I remember correctly. And he has authored several manuscripts, several articles, and also a few books, among which Time to Contact and Looking into Pictures, both two books that I really appreciate. So welcome, and yeah, the floor is yours. I'm looking forward to hear your talk.
Okay, thanks, Nuno. Good to see you, if only virtually, and thanks for the kind introduction. Yes, I will try to share my my screen. See if that works.
Yeah, you should be able. Yeah.
Does that do the trick?
Yep.
Okay, good. I need to move my windows around a bit. Okay, now I see you and I see my presentation. Isn't that nice? Okay, so what I will like to do today is, now it doesn't advance. Oh yes, it does advance. Okay, talk about personal, interpersonal space. So what does that involve? It's sort of at the border between perception and social psychology, if you will. So as we position ourselves with respect to other people, we have certain space requirements. And there is a zone, obviously, where we feel uncomfortable. If somebody approaches us too closely, somebody we don't know intimately, we feel uncomfortably. And if somebody wants to communicate with us and is too far away, we don't feel comfortable. So there's an obvious comfort zone, and this has been talked about in terms of an equilibrium between approach and avoidance tendencies in social psychology, going all the way back to Kurt Lewin. And in particular, as far as personal space goes, there's a taxonomy introduced by Heiduk, which she came up with in the, I think, 70s and 80s, where she says, okay, here's intimate space where we like to touch another person. There's personal space, which refers to, well, what I consider my bubble, my area that I want to control, which is about 1 meter in radius, and then beyond that there's public space. There's other taxonomies, but this is sort of the most prominent one. And there's one interesting study, not without problems, but one that I would like to go into a little bit, by Zorokovska and colleagues. There's 100 authors on this. So people from all over the world have presented a paper and pencil test that you see here, where people should just basically mark with a little cross where this person should approach the other for a good interpersonal distance. And on the right here, do you see my cursor? Okay, we have the results. So this is the question. They asked a question for social distance and for intimate distance and for public distance, so to say. So this is the social distance here, which is for Portugal 1 meter and 15 or so. For Germany, it's pretty exactly 1 meter. And we can speculate about why in Portugal you guys need a little more room than we do here. Maybe population is not as dense. Such studies have been done before, and every time it's done, the results come out differently. So I wouldn't base too much on this, but here they've rank ordered the countries, and you see that there's about 75 centimeters in Argentina and 1 meter and 50 or so in Romania. So there's some variability around roughly one meter. And given that this is a paper and pencil task with questionable silhouettes here, one could have doubts about how well this transports to real life situations. As we will see, it actually transports reasonably well. Here is the personal distance, which on average is a little closer. So they've asked the question differently, and they get a different rank order now. So the countries are in the same order, but the results are different. So depending on how you ask the question, you get somewhat different results. So this is an interesting study, cross-cultural study that indicates, well, there may be cultural differences, but the need to have about 1 meter space seems to be pretty universal. There is a vast literature on this with very different dependent variables and very different questions, all of them, most of them pretty qualitative, from the 60s and 70s. And then it has received recent interest. But so there's this old interest in the founding fathers of social psychology, and then there was a surge in the 60s and 70s. But the idea that seems to be prevailing is that there's sort of a bubble we have around us. So this immediate space and the need for space and distance seems to be like a bubble that is concentric. But this has never been tested. The problem why it may not have been tested is because everybody uses a different method, and obviously depending on the context, very different distances are afforded, right? If you're in a crowded subway, things are different than in the desert where you're very happy to see somebody, and so on and so forth. So what we've done first is we've decided on a scenario that we would use in our experiments always. And the scenario is as follows. Imagine you're in a place that's not very populated, and there's a strange person you've not met before, but whom you want to ask for directions. So a non-threatening stranger, and you ask, well, sorry, how do I get to the marketplace or something like that? So this is the scenario that people had to imagine, or that we put them in actually on outdoor space. And then they were to walk up. So they always start at a distance beyond 2 meters, so 2.5 meters or 3 meters away from an experimenter, and they approach this experimenter up to a point where they think, well, this is appropriate. Now I would ask a question and engage in a conversation. And we noticed that right away we would run into problems like, okay, if the person is really tall or really small, things will look different, and so on. So that's what we decided on. What I will do now is present you a number of experiments. First, where we try to map out the personal space. So the question is it really a bubble? Is it concentric, or has it some other shape? Then what happens if you approach too far into somebody's personal space, and what if you recede too far? is this equally uncomfortable? Or is it, as one might suppose, is it a lot tougher to get too close? Is it more uncomfortable if people are too close as opposed to too near? I imagine a situation on a conference poster session where I talked to somebody, I think was from Saudi Arabia, I forget, anyway, an Arab country, and the person was talking to me about my poster and was really uncomfortably close in my face, so I receded, and then he would immediately step up until I was back against the wall, and I couldn't. So he obviously had a very different intuition about the appropriate distance than I did, and so I was uncomfortably close, and he was uncomfortably far. Then we want to go a little into how people regulate interpersonal distance, how that might be different in different conditions, clinical conditions. How do external factors like hair color and now in our corona era, the face mask interfere? And then finally, I'll talk about mirrors because that's just something I like to do. So what is the shape of personal space? Is it really circular or is it dinted in the back? There has been only one study that really looked at this. And that was a study by Balanson and Jack Loomis's lab, where they've done the following. They've created a virtual reality, and in this VR room was an avatar with a t-shirt and some print on the t-shirt. And subjects had the task to read what was written on the t-shirt. And by way of head tracking, the experimenter recorded how close the subject would come to this. And there they found a big dent in the back. So let's see if I have data here. No, I don't. So I think that the difference that people assumed was about 1 meter in the front, but when they approached from the back and read what was printed on the back, it was 1.30 meters or so. Sorry, it was closer. It was 80 centimeters or 70 centimeters. So Balanson and colleagues, excuse me, argue that it's not spherical, but it's basically where you look. So it's dinted in the back. It's very short in the back and very wide in the front. And that was the only study up to the point where we looked at it that had investigated the shape. And then there were several studies about gender difference, showing that women approach closer than men, and two men approaching each other hold the largest distance. So that's something we wanted to ascertain. So we were warned that body height might be a problem, and that the particular problem of using the indirect task where people had to read what's printed on the t-shirt and maybe it was more crumpled in the back and that's why they approached closer. So we decided to have an explicit task where we asked people to approach and stop when they had the appropriate distance. And we also wanted to match people in terms of body height. So what we did is we found matching pairs of students who had not seen each other, so first semester students who were not friends or well acquainted to one another. We matched them in height, so we asked them how tall they were, and then found pairs of the same height. And we also added a mannequin to see whether it makes a difference, whether we use a mannequin that has a fixed facial expression, everything, or a live person, and to make sure that that there's not an asymmetry in the negotiation process, right? If you approach a person, usually the passive person signals by alarmed gaze or whatever it is. Oh, you're coming too close, or here, come closer. I can't hear you. So we wanted to have the judgments from the active person and the passive person. So we asked the passive person to give a rating for whether this active person was too close or too far away for the situation of asking for directions. There have been findings that the passive person allows more closer up distances, but this was in a different context and not up to modern standards study. And then eye contact seems to be playing a role here. We've actually ascertained that eye contact is not really that important if it's emotional expression rather than the eye contact. So here's what we did in this study. We had 33 pairs. We did it all in a big laboratory space here in Mainz, and had the one person play the active person and then switch roles, and the other person played the active one. Always the passive gave ratings, and then we had both approach the mannequin, and we asked for attractiveness of the other person and degree of acquaintance. We had also different approach directions. So 0 degrees is a direct frontal approach, and then we basically made the circle complete here. So we had the active person approach from behind, from each side, and the active person at all times was able to turn the head and look behind. So we did not constrain them in any way. They just had to stand there, and so they would be aware where the other person was in the room. So here's a photo of the mannequin. How did we measure interpersonal distance? We had these wooden contraptions here that we put behind the heel of the person. We had a laser distance meter, and then subtracted half the shoe size from the measured value, so that we would get the center of the body axis, roughly the center of the body axis. So what all the measures that you see are basically from body center as well as you could measure it. And here are the results. I don't know what happened here. So what I've plotted here is the space, the judged distance for the active person, and it is roughly 1 meter in radius and roughly concentric. So the female pairs got closer. They're a little less than 100 centimeters, more than 90, 95 centimeters. And the 2 male persons kept the largest distance, the male somewhere in between. And yes, it's not perfectly symmetric. There may be, for the males, there may be a little larger space requirement in the rear. So it sort of makes sense, right? If you're in this fight or flight scenario, and you look over your shoulder, then of course somebody in your back is more threatening. So there's a small effect here only for the male pairs. So if anything, the personal space is a little bit enlarged in the back, and this is quite the opposite of what Berenson and others found. So this is what we found here with a large sample of people. We also find the same pretty much circular shape with the puppet here, the mannequin. The interesting average result is here that the puppet that was judged not to be very attractive, actually a little creepy, was put at almost 1.20 meters, whereas people would be put closer to 1 meter. And here we have 0 degrees is the frontal approach. So we have, in the sideways approach, we have a little less distance here for the puppet. So that's probably because you don't look the puppet in the face anymore, and it doesn't look quite as gruesome anymore. So that's the results here. Now, what's really very nice and very interesting, the passive judgments of, is this too close, too far, perfect, is exactly on top of the active distance that was assumed. So basically, the impression of the passive person matches perfectly the distance that the active person has chosen. So you could interpret this as a distance negotiation, right? They both were happy with the distance that was established between the two, no matter who was active and who was passive. So presumably there was a negotiation going on, and they agreed on a distance that was just right for everybody. So no difference between active and passive. We pretty much replicated the gender effects from before. Males among each other hold the larger distances, and females approach a little closer. We later showed it has to do with attractiveness. So male person approaches a female closer when she's judged to be attractive, and vice versa. The mannequin looked a little uncanny, so that's probably what's going on here. So this is the first experiment. We pretty much have a circular personal space that's roughly 1 meter in radius, very circular. We have in the planning an experiment where we use a drone to see if it's actually also 1 meter above and below, if possible. So if it's really a bubble, a circular bubble, or if it's more like a ring or a donut or something. Now here, the next question we asked is, well, is there a discomfort function that applies? So is, as mapped out here, is it really equally uncomfortable if the other person stands too far or too close? Or do we have a model more like this, where when the person gets too close, it gets uncomfortable very soon, and if the person recedes, it sort of is a very shallow change gradient? And is this an immediate response, or is this sort of a very sluggish response? That was sort of the idea. We read up on Kurt Lewin, who came up with this idea of interpersonal space and of resolution, right? So if you have an object here that's attractive and another one that's attractive, if they're equally attractive, you're sort of torn between the two and you can't approach. You're stuck there. And as soon as you get a little shove, you then drift toward the one. So there's a gradient of that attractiveness space as a function of distance. We tried to look for a quantitative way that we could find in Lewin, and basically realized that he had given up on it. He had tried to mathematically describe the exact field forces and gradients and gave up on it. He said it's just mathematically too complex. There's too many variables that enter the equation, and he sort of gave up on it. We similarly gave up in the sense that we didn't come up with a formula, but what we did do instead is we proposed 4 alternate models here. So we said, okay, one could predict fast response, symmetric, fast asymmetric, sluggish symmetric, sluggish asymmetric, and then took a new set of data where we placed people in a given position and then asked them to give either a verbal rating of comfortableness. So when it was just the perfect distance for the same situation, they should give the top rating. When they thought it was really uncomfortable, and so forth. We had verbal ratings, and to make sure that there is no problem with this rating scale, we also have this joystick that you see here. So people were asked to give an analog rating. The farther they pushed the joystick, the more uncomfortable the distance was. So when it was too close, they should push this way. When it was too far away, they should push the other way. So we basically had several measures. 24 subjects did the task here, and it was from, so here's the distances. They ranged from 40 centimeters, which was clearly inside the 1 meter personal space, and we had distances of up to 250 centimeters, because that's where we usually started out in the other experiments. And then we measured from minus 100, really uncomfortable, to plus 100, perfectly comfortable. Plus 100, uncomfortable in the other direction, too far away. So 0 is perfectly comfortable, minus 100, way too close, plus 100, way too far. And here is the average plot for the different conditions. So the passive verbal rating gives us this, the active verbal gives us the dotted here, and the passive manual gives us, so we have very similar functions here. It looks like they are pretty fast responses, and they're not symmetric, there's asymmetric. Approaching too close is more uncomfortable than not approaching far enough. Here, I apologize for the problems here in the presentation. I don't know why this is, if this is an interaction with Zoom or what happened here, no clue. We then sort of normalized the data to a common 0 point. So for each individual where they said this was perfectly comfortable, we put the 0 points on top of one another rather than using the raw ratings that you just saw. And we see that they fall very nicely on top of each other as far as the slope goes. And we have this fast response that's asymmetric. A approach too close is deemed more provocative and more uncomfortable than an approach not close enough. This can be quantified, so the repelling forces that you get when you approach too close are about 6 times stronger than the attracting forces when you approach too far. And what we've seen in the literature, there's some papers who find sort of U-shaped function that obviously is not correct. They've sampled too few data points or aggregated. So basically what we should do is we should redo our definition of personal space. It is a field, or it could even be conceived of as a bubble, but it has a steep gradient for intrusion and a shallow gradient for extrusion at a ratio of 1 to 6. So we now have a sort of a better definition of personal space. So this was sort of the second main experiment that we did. And after that, we've done all kinds of variations on the theme. First of all, we wanted to know if we can port this to avatars. We've actually done one experiment in a sort of experimental class that's not published, where we had this mannequin and then just glued different emotional expression photographs from a database onto this thing. And we found that with a happy face, people would approach closer than with a angry face and so on. So we assume that emotion is important, attractiveness is important, and so on. But to keep those variables controlled, you have to go to an avatar. You can't have actors well enough and replicable enough. So we basically first replicated this with an avatar on a big projection screen. Here, this little thing here is an Xbox Kinect that basically captures body position down to a centimeter in precision. So we had the subject stand here, get captured by this device, and then move to a 3D avatar that was the same height and presented in 3D stereoscopically with shutter glasses, so that we can then decide and measure how close the subject is. Here is a picture. So this is the avatar here seen in 3D by the subject. This here is the subject with the shutter glasses. And we had avatars approached at different angles by 20 subjects. We had a male and a female avatar, and we find a pretty perfect replication of our results. So males approach closer to the female. The radius is about 1 meter, and it works beautifully. So now we use this and asked, well, how do interpersonal distance preferences correlate with personality traits? So we did a big screening and looked for students, healthy students basically, who would score high on psychopathy and others who scored low, and then did this task with them. This was the doctoral thesis of Robin Welsch. I think, Nuno, you've not met him, I believe. I think he was not here yet when you were here.
No, I think I missed him for 1 year, maybe.
Yeah, I think he started after you left, and he's now gotten his PhD. He's in Munich right now, in a nice virtual reality lab, actually. And so he looked at that in two different paradigms. So this paradigm here, and then a second paradigm where he measured reaction times. So basically, the avatar was in one condition, right, asked to be pushed away when the face was happy, and to be pulled closer, the joystick that is, when the face was angry, or this thing was reversed. So we have an approach avoidance test based on the facial expression and reaction times in the case where the mapping was this is Simon task-like, right? So you have a congruent mapping. The angry person whom you want to push away actually is asked to be pushed away or asked to be pulled close. So you have a compatible mapping versus an incompatible mapping. And one would expect a Simon effect here. And the question is this Simon effect attenuated in psychopaths or not? And the same as the interpersonal distance. So we would have two different measures of the same thing to see if this interpersonal distance measure would actually prove useful in this particular case. Here is a subject at work here, and you can see the details. Here are the results. So we have on the left the low scoring subjects, and here is plotted the reaction time difference between approach and avoidance, and you see that this difference is a lot larger in the low psychopath students as opposed to the higher ones. So it seems to be the case that the effect of emotion on this approach avoidance test is smaller in people with a psychopathic leaning. These are not diagnosed subjects. So there seems to be a nice correlation here. The next thing we did is we asked people to physically approach, and we recorded their space-time curve. So we have a very nice curve where we can see how quickly they approach, or how reluctantly, or whether there's reversal in the, do they go back and forth? Do they approach quickly or slowly, and so on? So we have a whole bunch of measures that we can correlate with particular variables, such as facial expression of the avatar and personality traits of the subject. And we basically find from several of these studies in a converging manner that what seems to be the case here in psychopathic individuals is that they don't have different averages. So they approach just as far as others, but they do not differentiate as well as healthy people do, or perfectly normal people do. So they don't differentiate between the different emotional displays of the avatar, which is a nice finding. And we have sort of done, but another one, I'll get into that quickly with patients actually. So yeah, virtual reality seems to work, and with this particular approach paradigm, we have a nice set of dependent variables, and now we can go and look at other effects. So, but first we wanted to know, can we port this virtual reality with a life-size avatar in a real room, so to say, to the goggles? And here you see a little video of what it looked like. Imagine this the stereoscopic display. So we have the advantage that we can do it in a small lab. We used an HTC Vive with motion tracking, where subjects could freely move their head and then perform a bunch of different tasks. We created avatars of different body weight in this case here. There are nice software programs that let you pretty much model different body mass indices. So you can change the amount of muscle and fatty tissue on the hips and so on and so forth. So these are avatars we created at different body mass indices, male and female avatars. Here, the viewpoint isn't quite correct, so they may look a little funny. They look pretty good in the head-mounted display. So we basically have body mass indices from anorexic to clearly obese and everything in between. And we basically wanted to know, well, what is there a tendency to change approach distances as a response to body mass index? And there is. It's kind of sad, but it's a beautiful curve. So we have a very nice U-shaped curve. The closest approach is to ideal weight. So on the athletic skinny side, it's just the sweet spot, and then the really skinny people and the really fat people, we keep more distance. Beautiful data, beautiful curve. Lets you think about social prejudice, doesn't it? But these are the data. So very, very nice data. And now the question is, can we use this in a patient group? So here we teamed up with a clinical psychologist, Tanja Legenbauer, and had very professional diagnosis. We used subjects with a diagnosed eating disorder in therapy. And I think the rule was they needed to have fewer than 3 therapy sessions. So this is usually 25 sessions in a behavior therapy, and they had a maximum 3 sessions. They were diagnosed and had not more than 3. So 25 female patients and 28 healthy female controls. And here's what you see. The U-shaped function shows up in both, interestingly, pretty parallel. And the eating disordered subjects kept a much larger distance. Here, 30 centimeters more, so this is substantial. So they stayed farther away from everybody. So in conclusion, you can develop, in theory, we haven't done this yet, we still need a student who's interested in doing it, but you could develop a therapy unit where you ask patients to approach at the values normal for healthy people and tell them that this is okay, this is good, this feels good, whatever. Right now, they often confront patients with their own silhouette. So they basically paint their silhouette on the wall and then say, look, this is how skinny you are, or whatever. They confront people that way. Here, it could be done in a much more convincing fashion with an avatar and direct feedback about what is normal and what isn't. This may or may not come in handy, but I think this would be nice to do. So this here we have the interpersonal distance in centimeters per body weight in terms of body avoidance ratings, so to say. So you see that the higher the body avoidance score in the test, the higher the preferred interpersonal distance in patients, but not in healthy people. So this is another way to evaluate the body avoidance questionnaire. It works beautifully, right? It shows that the higher the score here, the larger the interpersonal distance preference. So we have if you will, a very nice implicit measure of body avoidance that we can use by using this paradigm of interpersonal distance. So the data look very nice. Now, here's something completely different. Color. This all started out again in one of those experimental undergraduate classes where we let them run wild and do an experiment. And I said, okay, here, come up with an experiment of interpersonal distance. And I think I suggested hair color. So what this group did is they went, this was before Corona, they went to our campus and put up a huge board so that everybody go through this passage was basically channeled to go all the way to the left of the passage because there was this board in the way. And then they placed one experimenter with dyed hair on the floor, sitting there on the floor where all the passersby came out. And there were thin lines on the floor that another experimenter then could use how much of a detour the subjects would take. So how much of a detour would they do to not collide with the person with the colored hair? And we measured the detour as a function of hair color. So we had 2 experimenters or 3, I forget, with natural hair blue hair and red hair. And these were pretty bright colors. So we had them there for one day with blue hair, one day with red hair, and one day with natural hair. So they had to shampoo out the dye at night and so on. And sure enough, the red hair detour was the largest, then came the blue hair, and then the natural. So they found a very nice effect. The data were variable, and the question was, well, did they measure really well, and so on. So we redid this recently as an online experiment, where we, let's see if I have, where we first described a person and said, okay, here, look at this person. And these, by the way, are all deep fakes. So these are unreal people. They don't exist. They've been faked from millions of pictures. And then we photoshopped hair color. Here you can see that probably the saturation and lightness are not perfectly matched. So we're currently redoing it with different intensities, different lightnesses and saturation matches. But anyway, these were the stimuli. So we, and on the monitor at home, every monitor is different. So right, there's a limit to the control of the color here. But we have these three colors: red, blue, green, and natural. We showed them the image, then in big, then showed them this image here with a silhouette, and I think we may have mounted a little black circle here that for some reason doesn't show. And we asked them, okay, now please take this line, this is you, and push it to a comfortable distance for the case where you ask the person unknown to you for directions. And this is the person here. And again, we measured distance. We took the average female German person. I think the average is a 170 centimeters, say. And we matched this distance here to the distance produced by the subject, computed it into centimeters, and here's what we find. We find that people prefer a distance of about 160 centimeters. And who knows why it's not 100. It may be the funny silhouette, it may be the deep fake image that looks really eerie, who knows. But anyway, it's larger than what we typically find. It could also be that in the software that we used, it came out funny. I don't know, it looked good on my monitor. Anyways, what's interesting here is the effect. So the dyed hair produces significantly larger differences. And here, red is not the winner. Green and blue and red, they all seem to produce about the same difference. Green was a little more than blue, and I think it is the saturation, right? And in one model, green looks kind of dark, and another it looks a little brighter. Here in this model, the red doesn't really come out as too unnatural. And sure enough, the average distance for this head was larger than for this. So anyway, this is something we're playing around with, but there seem to be color effects that we were able to replicate. Color dyed hair produces more of a distance. So next time you dye your hair, bear in mind that this will introduce larger preferred distances. Do I have a few minutes? I think I said 45. I'm probably.
Yes, please go on.
Okay.
Yeah.
So given the Corona madness, we've done mask experiments. So we have this wonderful mannequin that's really tall. It's about 187 centimeter tall female, so much taller than average, and it's quite cleaning lady got really frightened. We put this mannequin up in a storage room right behind the door. And when she went in there and this mannequin stood there, she freaked out. So we had to bribe her to not quit her job. So very convincing mannequin. Here to make it a little less frightening, we took off, and to make the mask invisible, we took off the hair and asked people to approach this mannequin in the following conditions. Here, the subject wears a mask, the mannequin wears a mask, and we have subject mask, mannequin no mask, and vice versa. Here's the results. So when the subject wears a mask, they go a little closer. So this is reflecting you could assume the security that the mask provides, even though the mannequin is not contagious. But so there's an effect there. And there is a very nice effect of the mannequin wearing a mask. So when the mannequin wears a mask, subjects also approach closer. So beautiful data. The mask causes closer approach, no matter whether you're wearing the mask or whether the other person is wearing the mask, even if the other person is a mannequin tested negative for the virus. So this is our corona experiment. Here, an experiment I was not involved with that other people from my lab did. This is data from a paper and pencil task taken before the crisis in 2019. During the crisis, in March, I believe, in April 2020, and what's called post-crisis, was taken in the summer, or late summer, when things looked pretty good and restaurants were opened up again. But masks were still mandatory in public places and in public transport. So we see that in this paper and pencil experiment, the average, this is all online on the private iPad or personal computer, about 120 centimeters was average. Before the crisis, it went up to 180. So this is a very considerable increase, and then didn't quite normalize. And we're going to redo this at intervals as time passes. So the mask obviously creates quite a bit of distraction and difference here in interpersonal distance preference. So finally, a mirror experiment. We know that people are lousy with mirrors. So here's the experiment I did a long time ago. Imagine, this is a paper and pencil task. Imagine Jane comes through the door and here's a mirror. Where does she start to see herself in the mirror? Please put a cross where you think she starts to see herself. Is it right when she enters the doorway? Is it well, anywhere on this trajectory? The true answer, of course, is as soon as she catches up with the edge of the mirror. A few people say, well, as soon as she can see the mirror. Quite a few say, well, about here. And then some know the correct answer. So why is it that a substantial amount of people think that one should see oneself in the mirror way before this is actually the case? What happens to interpersonal distance in the mirror? We usually shave ourselves in front of a mirror or draw our lipstick so we know where we are with respect to the mirror. We see other people in the rearview mirror of our car and so on. So we did this experiment with 4 conditions. Please approach the person in the mirror up to a comfortable distance. Pretend this is a stranger. How close would you get if you asked them for directions? Approach another person in the same lab space. Now you're the observer. How close should this person walk up to this other person there? whom she sees in the mirror, and do the same with real people. So these were the 4 conditions. Here is where you approach sort of yourself. And this here looks right to this person. So these are the results. When I'm in front of the mirror, I go on average 65 centimeter in front of the mirror, which is too close, or rather not close enough to the other person if the person were virtual, and too close if I judge the distance to the mirror and take the mirror to be the point to reckon with. Here's when the person is farther away, so this looks right to us, but not to the person in the mirror. So we basically find pretty much 1 meter, 1 meter 10 in all conditions, except when I'm in front of the mirror and I judge myself, I approach too closely. So when I judge myself, I somehow average between the surface of the mirror and the person in the mirror. And in all other cases, I basically use 1 meter to the mirror or 1 meter to the other person. So this just as an aside. So in the future, what we want to do is we want to look a little more at 3-dimensional space. Is it really a spherical bubble? We want to look a little closer at virtual reality's intrusion and extrusion there. We want to look take a closer look at the discomfort exchange function, and maybe look at other measures and other contexts. So we will continue this research. So let me wrap up. What can we conclude? Well, Kurt Lewine's conception of personal space as a force field around the person is certainly viable. This force field is circular. It has a radius of about 1 meter, and it is anisotropic in the sense that the force field gets a lot stronger when you approach too close and doesn't cause as much discomfort when it gets too far. The paradigm transports really well to virtual reality and to some extent also to paper and pencil tasks. It's a very promising tool for indirect measures of attractiveness and so on in clinical contexts. It's a nice measure that should be pursued, and we can certainly elaborate and use this measure in different clinical contexts. This is Robin Welsch, who basically did most of the work. So this was his dissertation. And these are other people. You may remember Agnes Münch, Nuno. She programmed the virtual reality. And this here's the commission. And Christoph von Castell, a current postdoc. So thank to my colleagues, thanks to you for listening, and I'm happy to take questions.